Hi, I'm Alec,
And I'm Michael.
and today we'll be doing a calculus level optimization problem. Optimization is when you have one variable and you're trying to maximize it while considering your constraints. So let's look at this problem. Your task is to create two fields that border a river. You have 500 feet of fencing, and you do not need to put fencing next to the river. What is the maximum amount of total combined area these two fields can have? So first let's draw a picture. So we have our river. In this case, it's a perfect river. Right here. Put an R there. And now we have to make our fields. So fencing and fencing, and the top layer of fencing. And no fencing needs to go here, because, like the problem states, there needs to be no fencing bordering the river. Now, the thing is, we need to have two fields. So nowhere in the problem does it state that the fields need to be equal or of whatever certain sizes. So we can make the division between these two fields anywhere. So I'll just put it here. So now this is our picture, and let's label it. So we know these three are the same, so we'll call them x, 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 and x. And we have no fencing here, so the last bit of fencing is up all the way along here. So we'll call this y. So the first thing we want to do, now that we have our picture, is to create our equations. So we need to consider area, because that's what we're trying to maximize. So area of this two fields is just x times y. So area equals x, y. Next, we should consider our perimeter. So our total fencing is 500, and here's the instances where fencing is used. So we have three x's and a y. So perimeter equals 3x plus the y plus y. And we also know the perimeter equals 500. So we'll make that equal to 500, as is stated in the beginning question. So now some things to note. Some areas where people might go wrong is first, you need to remember that you don't need to consider the side. So a key thing, you just need to know in your problem, whatever it is you're doing, if it says that it has an open box or a not used side, remember not to include that side. So we have no perimeter there. So now, to get going in this, if you notice, we have x and y. We can't really solve it with two variables. So we want to reduce the amount of variables. So we can do that by putting one variable in terms of another. So let's take perimeter, because we know what that is equal to, and try to put it in terms of another. So I'll subtract 3x on both sides, and I'm left with y equals 500 minus 3x.
Alright, now that we have the perimeter equation in terms of y, we can now substitute the y into the area equation. So now we have area is equal to x times 500 minus 3x. Now we distribute the x into that to get area is equal to 500x minus 3x squared. Now, since we're maximizing the area, we want to take the derivative of the area equation. So the derivative of this would be equal to 500 minus 6x. Now, in order to find the x, we have to set the equation equal to 0. Getting 0 is equal to 500 minus x, add 6 to both sides. To get 6x is equal to 500, making x equal to 250 over 3, which is also equal to 83.333. Now what we do is we can take the x and put it back into the perimeter equation to find out what y equals. So now we have y is equal to 500 minus 3 times 250 over 3. So the 3's cancel out, getting y is equal to 500 minus 250, making y equal to 250. Now that we have that, we can plug both the y and the x into the area equation to find out the total area. So area is equal to 83.333 times 250 to get the area to equal 20,833.25 feet squared.
In conclusion, make sure you know what variable you are optimizing so you know which equation to take the derivative of. And remember to know where your perimeter and your area actually apply with your picture.
Thanks for watching.